After this, before moving on to non-ohmic resistors, let's do another small derivation about what? See, that derivation is actually included in your solids and semiconductor devices. That is the second last unit of your plus 2 syllabus. But because there is another term called mobility, we will include the derivation right here. We will not go into much detail, and I will tell you at the end how to do that derivation just for current electricity. But consider the fact that what are charge carriers? Charge carriers are those free moving particles which carry charge, right? So are charge carriers always electrons? No. You already know this, that ions in case of gases and what? Liquids, cations and ions, they are also charge carriers instead of electrons. So there are any other type of charge carriers as well? Yes, there are. These are called holes and electrons. So in case of semiconductors, the charge carriers are electrons, which are negative charge, and holes. Holes are positive charge. Alright. So this derivation is actually for electron current and hole current. We are not going to detail for holes right now. I'll explain you that as well. Why? See, all you have to know for now is that there are holes as charge carrier in solids and semiconductor devices. Now, what is the formula for current? Current is I equals to NEAVD, right? But in semiconductors, there are two charge carriers. That means there will be two currents, electron current and hole current. So similarly, our formula would change into this thing, NEAVD plus NEAVH. See the changes where I am doing. This was drift velocity, this was charge density of electron. So here I am writing E, this is drift velocity of electron. Similarly here, this is charge density of holes, this is drift velocity of holes. Alright. So once we will finish off this derivation, you can rub or you can erase whole of this part to get the values for current or the electrons only. So that will be the derivation, that will be the formulas which you guys will be using in current electricity chapter. Alright. Moving on. If I take A common out, you will be left with any charge density of electron. Also take E. We can take E common out right now, but we don't need it. Drift velocity. Okay, let's take E also out. So you will be left with NEVE plus NHVH. Alright. Now, bring this A down. You will be left with I upon A. What is I upon A? Current upon area of cross section which current is flowing is called current density. So this will be equal to J, which will be equal to E NEVE plus NHVH. Mark this formula. This is one of the formula for current density in terms of drift velocity and charge density. Alright. Moving on. We have J, which is equal to I upon A. See the steps involved. I equals to what? V upon R. V equals to IR. So V equals to IR. Where is that? This. I equals to V upon R. V upon R into A. Right? V is in terms of electric field. What? E into L. E was V upon L. So similarly, R is rho L upon A. This R, this V is changed into this, and this R is changed into this part, into A, right? This A cancels out, this L cancels out. You are left with electric field upon, what is this? Resistivity. So just take this whole thing and this whole thing, that current density is equal to electric field upon resistivity. So if this part is visible to you guys, I'm not going to remove anything right now. I'll be writing a bit small now. I'm starting with this point. Instead of J here, I'm using this part, electric field upon resistivity. This is equal to NeVe plus NHVH. Okay, H is, if I move a little back, I'll be out of the screen, so I'll keep on speaking. N for the last time, this is charge density, V is drift velocity for electron here, V is the drift velocity for holes here. This is H, alright, holes. Now, 1 upon resistivity. What is 1 upon resistivity? Conductivity, which is represented by what symbol? Sigma, right? Is equal to, I have taken this electric field down. So, NeVe plus NHVH upon this electric field. Have I left anything here? Did I miss any point? This electronic charge, I forgot to write. So, E, this and this, right? So, moving on, sigma, alright, you have to remember this is the another formula for conductivity in terms of charge density and drift velocity with electric field as well. So, sigma equals to E. I am taking this electric field separately with both the terms, right? So, it would be NeVe upon plus NHVH upon E, right? Instead of writing like this, my next step would be, I am taking this electric field only with the drift velocity. So, C plus NH upon NHVH upon E. This is what I did here. I have taken electric field with both the terms, and then I have taken this electric field only with the drift velocity. Here is that term I was talking about, which we still have to introduce. This is called mobility. What is mobility? Mobility is drift velocity. The definition is mobility is drift velocity per unit electric field. So this is drift velocity upon electric field. So this becomes mobility, and your equation becomes sigma equals to E Ne mu E. Mu is mobility. It is denoted by mu. If you want to know, I am writing another formula for mobility. I should fix it somewhere here. Ninth formula is mobility. Mobility is drift velocity per unit electric field. This should be the ninth formula. Eighth, we are coming to that point. Ne mu E plus NH mu H. Alright. This is the final formula which we were looking for today. This is what the conductivity in terms of charge density and mobility. So I am writing this formula right here. This is sigma is electric charge, charge density, mobility plus charge density for holes, mobility for holes. Now this is the formula you should remember, but you can also do one thing. Since you will not get the actual value or meaning of what holes are, start doing this, or don't write the values for holes at all. Alright. So accordingly the change would be, this will not be included in the formula, right? So your formula would be limited to this point only. What is this? Conductivity is electronic charge into charge density into mobility. Exactly. Remove every whole term from this side. So these were all the main formulas which you guys will be using to solve numericals in current electricity.